I am Pijus Bairi, Assistant Professor of Department of IT, Haldia Institute of Technology. Today I am going to discuss something about the binary search tree. So the topic to be discussed is what is binary search tree, the need of binary search tree, what are the different benefits of binary search tree, what are the different applications of binary search tree, and the last one is the disadvantages of binary search tree. So the binary search tree is basically one binary tree which where the nodes of the tree are arranged in a specific order. So the binary search tree maintains all the properties of the binary tree, and besides this property, binary search tree have some additional properties. First property is the left subtree of a node contains only nodes with keys lesser than the node's key. And second property is the right subtree of a binary search tree. The right subtree of a node contains only the nodes with the key value which are greater than the node's key value. And the third property is the left subtree and the right subtree of a binary search tree are also a binary search tree. Now if we find the figure the figure in the right side are an example of is one example of binary search tree. Now if we find this tree, the root is 50 and the left subtree of this root contains the data element 20, 30 and 40, which all are less than 50. If we consider the right subtree of this binary search tree, which contains the data element 60, 70 and 80, so they are all greater than 50. So the left subtree contains the data element which are less than 50 and the right subtree contains the data element which are greater than 50. So these are the first two properties. And if we consider the subtree of 50, there is a left subtree of 50 which consists the node 20, 30 and 40. The left subtree is also a binary search tree. That is 20 is less than 30, so it is at the left subtree of 30, and 40 is greater than 30, which is at the right subtree of 30. Similarly, if we consider the right subtree of 50 is headed by the root node 70 and 60 is less than 70, so 60 is at the left subtree, and 80 is greater than 70, so 80 is the right subtree of 70. So this is the third property, that is the left subtree and the right subtree of a binary search tree is also a binary search tree. This is recursive in nature. Now the next one is, why do we need a binary search tree? The first point is the linear data structure like array and linked list are inefficient for frequent search operation. If we store the data in array as well as in linked list, we will see that if we perform the searching operation in case of array and linked list, the complexity of this searching is order of n. But if we perform the searching operation in case of binary search tree, we will see that the searching operation takes less time as compared to less or equal to order of n. So as the binary search tree is an ordered tree, so we can perform the search operation, insertion operation and deletion operation very fast as compared to the array and the linked list. So and the third point is what? It provides an efficient way to organize and access large data set in a hierarchical manner. In case of array and linked list, we can store the data in a linear fashion. But in case of tree, in case of binary search tree, we can store the large amount of data in a hierarchical way, where the different nodes acts as an index to find the large data element. And the fourth point is it supports dynamic insertion and deletion better than static array. As we all know, the array is basically a static data structure. But if we consider the binary search tree, while we are inserting some data element or while we are deleting the data element, no need to store the data in a static way, but we can store the data in a dynamic way. We will create the node as per our requirement and we will insert the data. And while we are performing the deletion operation, the deletion can be done more easily. We will simply remove the allocated memory space for the element that has been allocated previous. So the insertion and deletion, as the BST is dynamic in nature, so insertion and deletion can be done in a better way. Now we will discuss what is the key benefits of the binary search tree. As we all know, the binary search tree is basically one binary tree where the nodes are arranged in a specific order, and as the nodes are arranged in a specific order, so it when we perform the searching operation or insertion or deletion operation, the time taken by this operation is reduced greatly. So that's why this is faster than linear search in array or linear search in linked list. Second point is dynamic resizing. As the array is static, but the binary search tree, the nodes in a binary search tree are created as per the data element. So it is dynamic in size. So we can create the different nodes as per our requirement, as well as we can delete the node by freeing the memory space as per our requirement. The third point is in-order traversal gives sorted order of elements. So when we arrange the binary, or when we create a binary search tree for some given data elements, we will see that the smallest element will be at the left subtree, or the smaller element will be at the left subtree, and the larger element will be at the right subtree. So if we perform the in-order traversal, that is first the left subtree, then root, then the right subtree, we will get a list of sorted elements. Last point is it is easy to implement in a recursive algorithm, as the left subtree and the right subtree of a binary search tree are also a binary search tree. So we can implement the recursive, we can implement the binary search tree in a recursive way. Now, the applications of binary search tree. The binary search tree have several applications in computer science due to their ability to store the data in a sorted manner, and it facilitates to perform the searching, insertion and deletion operation efficiently, especially when they are balanced. And the several key applications includes are it can be used in case of database where large amount of data is stored in secondary memory, and we can create the different index to search the data, as well as we can create the different lookup tables also, and both the indexes and lookup tables are maintaining the property of the binary search tree. In case of compiler, the syntax tree representations can also be implemented with the help of, or can be designed with the help of the binary search tree. In file system, the directory structure can also be implemented with the help of binary search tree. In networking, the routing tables are also implemented with the help of binary search tree. While you are performing the different search operation like the dictionary, then we can also use the binary search tree. And in case of memory management also, we can use the structure of binary search tree to find or to order the free memory space as well as the used memory space also. And if we use the binary search tree, then we can efficiently find the free memories, the list of free memory space we can easily find. And the last one is the disadvantages of binary search tree. Now the main disadvantage of binary search tree is that we cannot control the as the binary search tree in ordered tree, So the height of the binary search tree can be reduced if it can be if the data elements, if basically it depends on the order of the data elements, right? Now as long as the height of the binary search tree is low, then the operation, the different operation like insertion, deletion, and searching of element will be very less. But we cannot control the height of a binary search tree. Now if we see, we have taken two set of key values, but the key values are ordered in a different way. The first key values are ordered in a unsorted way, and the second key values are the same key values are in case of second set, the same set of key values are in a sorted order. So the key values are same, but their order is different. So depending on the order, we are seeing that the structure of the binary search tree is different, right? So if the data elements are in unsorted order, we are seeing the leftmost figure, that is the 25 is the root, then the left subtree contains 8, 13 and 17, and the right subtree contains 33, 41 and 28. But if the same key values are in a sorted order, then the structure of the tree is like that is shown in the right side figure. So 41 is the root, then 33 at the left, then 28 is also left, 25, 17, 13 and 8 are. So the structure with the same key values, but they are different order, we are getting the different binary search tree, that is their structure is different. So when we perform the searching operation, searching, deletion or insertion operation in case of left figure, then we can say that the time taken to search, time taken for the searching, insertion and deletion is less. But if we find the right figure, then we will see that the searching operation, insertion as well as the deletion operation is having no difference with the linear list, right? So in case of right figure, the complexity of searching is order of n, but in case of the left figure, the searching complexity for an element is order of log n. So as long as the height of the tree is reduced, so it will take less amount of time, and if the tree structure is like a linear list, that is the right figure is basically known as the left skewed binary search tree, right? So in this case, the complexity increases from order of log n to order of n. Thank you.